In this tutorial, we'll use Teledyne LeCroy's Sierra platform to modify the contents of a frame to create a check condition error on a SAS 12 gig physical link. The Infusion error injection system can change any field within the header or payload of a frame. You can create countless SCSI level protocol errors with this mechanism: invalid addresses, invalid commands, length mismatch, bad LBAs. And it can create these types of errors in real time on a live, fully operational system. On top of that, this is the only jammer on the market that can insert D words within a frame. By extending the length of a frame, you can now intercept a response packet, change the status good to check condition, and then insert the additional sense key and sense data to force dozens of different SCSI level errors. This is the only way to verify that your system can properly recover from these types of errors. Okay, let's get started. This slide summarizes the changes we'll need to make to create the check condition error using the Infusion jammer. The procedure requires that we modify several fields within the response frame, including the status field, which we change to check condition, and the sense data length. And then we need to insert 5 additional D words into the response, including sense key abort command and the additional sense key codes overlapped command attempted. This will create a duplicate tag error that the initiator must now recover from. Like our other examples, we'll begin by setting up the analyzer to capture the error. We do that by choosing New SAS Protocol Analyzer. We'll choose Pattern Trigger. Here, we'll choose SSP frame. We double-click and select Response. Within the response fields, you have the ability to select the status. We're going to choose to trigger on the first check condition that the analyzer sees. We click OK, and we have now added that as the trigger event. We go to the Settings tab. Let's make the buffer a little bit larger so that we can ensure we capture the recovery. We'll set a 30 meg buffer. And of course, anytime you're using Infusion, you need to go into port configuration and make sure you have the correct jammer settings. We're going to use AJA on port 1. With the analyzer now set to record the error, we'll switch to the jammer software where we'll create our test scenario. We'll start by using the New Scenario button. We're presented with a blank test scenario. Let's always begin by naming the scenario. We'll call this Check Condition Recovery. And in this test, we're going to be corrupting a response frame. Response frames are always from the target, so we're going to be changing the traffic from the target direction. Click OK. We'll use a sequence for this test case, and we'll begin by telling Infusion to wait for a SAS command frame. We'll use SCSI block commands, and we'll go to, this time, a write 10. Command frames are always sent from the initiator. We click OK. So we're waiting for our write command to occur. After that, let's go ahead and choose branch to a new state. In the new state, we'll now select waiting for a SSP response frame. Response frames are always from the target direction, so this is all set. We'll click OK. Now we'll choose Add an Action. We want to use Substitute Data DWORD in order to replace status good with status check condition. Here you may need to refer to the SAS specifications or at least be familiar with the layout of the SSP response frames. Infusion can replace a single bit, but it works on a DWORD basis, so you need to specify which DWORD. Remember, we first want to change the status to check condition and the sense data length to 2. There's a pop-up menu that allows you to select individual fields to replace. Of course, you'll find the status value here. Problem is that we want to replace two fields. So for that, we need to use custom mask and offset. This is the 8th D word from the start of frame, so we'll enter 8 as the offset. The values we want to insert are 2 for the response data and 2 for the check condition. And then the mask. We want to specify only the last 2 bytes of this D word. So we'll use FFFF to represent the mask for those last 2 bytes of the 8th D word. That's it. For this D word, we're finished. We can now manipulate the next D word by again clicking Action, Data D word. Here we can actually pick the Sense Data Length field from the pop-up menu, allowing us to manipulate just that single field within the D word. For this error, we want to choose a Sense Data Length of 12, and we're going to specify a mask of FF to cover that last byte. Okay, we've specified that additional sense length. Now we need to actually insert the D words that's going to make up that additional sense length. The Teledyne LeCroy Sierra is the only jammer on the market that can do this. We're actually inserting D words into the stream up to 15 D words at a time. We now need to instruct the Infusion system to insert the D words within a specific position. We're going to choose offset from frame start, and this is going to be 11 D words from the frame start. Now we simply need to define the contents of the D words that are going to be inserted in the stream. We're going to start with the response code 70, and then we're going to insert the sense key B, aborted command. These are data D words, so you can leave the K code mask untouched. To insert the next D word, you choose custom D word. We're going to specify the value of A, the additional length field. D word 2 represents reserved fields, so they'll be all 0. And D word 3, we need to insert the additional sense code qualifier, which is 4E. One more custom D word, which is all zeros as it's reserved as well. That is all of the D words we need to insert to create this error condition. It's worth noting that anytime you modify or insert D words in a frame, it's necessary to recalculate the CRC to provide a valid checksum. By default, the Infusion system will recalculate the CRC, so this field is all set. We'll press OK. Always save your work with the disk icon. Now, let's add one more action. We'll choose branch to a new state. In the new state, we're going to set a timer for 1 second. After the 1 second, we will restart the scenario. This will cause the error to recur approximately every 1 second or so. That's it. Our scenario is now complete. To review, we're going to wait for a write, followed by a valid response frame. We're going to substitute D word 8 with check condition and additional sense data length. We're going to substitute the sense data length value, and then we're going to insert 5 D words, including the additional sense code qualifier. We're going to restart every minute. Let's get ready to run our scenario. Of course, we want to make sure that we've specified that we're set for AJA mode. We'll bring up the Show Port Assignment dialog, and then we'll drag the new scenario check condition recovery to the port dialog window. Always start the recording using the analyzer first. Now we'll go ahead and click the Run button. We're looking for a trigger on the analyzer, and it looks like we have it. I'll stop the recording. The trace is uploading, and we're placed at the beginning of the trace at the first packet. We'll use go to trigger, which puts us right on the response packet that we triggered on and we modified. Rolling up to the command layer, we see, in fact, it is a check condition, aborted command, overlapped commands attempted. Let's go ahead and verify the recovery from the initiator perspective. I'll close that command and then hide the unassociated primitives. Here we see LBA AA78 with the check condition. Approximately 1 second later, we see the same LBA being written again. This time it's successful. So the host recovered from the error properly and retransmitted the right command. We see the check condition error is repeated a short while later, just as we programmed. The Sierra Analyzer software also includes a D-word level display, which can be very useful for confirming these types of error injection cases. It's called the column view, and it provides a chronological list of ordered sets where each D-word is time-stamped, and you can see the flow of traffic both upstream and downstream. I'll use the go-to trigger position to get back to the error condition we injected. Here we can see there are 2 recording channels which the software labels before jam and after jam, allowing us to see at the D-word level the traffic as it's being modified by the Infusion system. This is our initial response frame with the status good, and this is the response frame after the error injection where we change the status to 02 check condition. We can see all the changes we added, including the abort command as well as overlapped commands attempted. We can now use this test scenario as a model for creating other check condition errors that can be used for testing our host controller to make sure it can recover under real-world traffic conditions.